Welcome dear student. Today we shall study scientific reasons from lesson periodic classification of element, and this is for class 10th. Let's study. Alright, so first reason is atomic radius goes on increasing while going from left to right in a period. Okay, so first of all student, what is atomic radius? This is a distance between the center of the nucleus and a last shell of an element. Okay, so atomic radius goes on decreasing while going from left to right in a period. Why? So student, because the atomic number of the element increases. Okay, so we know that atomic number increases, that is there are total 118 elements. So atomic number of the element increases, which means that the number of protons and electrons in the atom increases, and the extra electron being added to the same shell. Okay, that means number of a shell will be same, but the electrons will added into the shell in the same shell. Alright, and due to large positive charge on the nucleus, the electron are pulled closer to the nucleus and the size of an atom decreases. So as the nuclear charge increases, the atomic size will be, or atomic radius will be decreases, and that is why the atomic radius goes on increasing while going from left to right in a period. Okay, so we have 7 periods. So as we are moving from left to right in a period, atomic radius will be decreases because nuclear charge increases. Alright, now next is metallic character goes on decreasing while going from left to right in a period. So why this is so? So student, because the tendency of atoms of the element to lose electron on gain electron changes in a period. So okay, so alongside you can observe the diagram, periodic table. So as we are moving from left to right, non-metallic character will be increases and metallic character will be decreases. Okay, so as we move from left to right in a period, the nuclear charge increases due to the gradual increase in the number of protons, and due to the increase in nuclear charge, the valence electron are pulled strongly by the nucleus, and it becomes difficult for the atom to lose electron, and that is why metallic character goes on decreasing while going from left to right in a period. Belonging to the Alright, now next is elements belonging to the same group have the same valency. So first of all, student, what is valency? So valency of an element is determined by the number of a valence electron. Now valence electron, that means the number of electron which are there in the last shell or outermost shell of an element of an atom. Okay, so student, all the elements in a group have the same number of a valence electron. That means elements belonging to the first group have the same valence electron. Alright, and therefore elements in the same group should have the same valency. And student, here I have mentioned two examples. It is example of a group 1, that is alkali metals, and example of a group 2, that is alkaline earth metal. So in group 1 we have lithium, sodium, potassium, rubidium, cesium, francium elements, and here if you will observe the electronic configuration of a group 1 element, that is the alkali metal, you will observe that in last shell, okay, in last shell of these element, the same, that is one electron is present. Alright, the one electron are present, but the number of shells are different, but the number of number of electron in the last shell or outermost shell is same, that is 1. So group alkali metals belonging to the same group, that is why the valency of alkali metals or group 1 metal is same. And while in alkaline earth metal, that is in group 2, if you will observe the electronic configuration of elements beryllium, magnesium, calcium, strontium, barium and radium, you can observe that in the last shell of this element, 2 valence electrons are there. That means these are belonging to the same group, that is why they have the same valency, that is 2. Okay, so student, that is why elements belonging to the same group have the same valency. Alright, okay, now next is the third period contain only 8 elements, even though the electron capacity of the third shell is 18. Okay, so let us see this periodic table. So student, this is a modern periodic table in which you can observe there are 18 group, that is 18 group and 7 horizontal period. Okay, so if this is a third group in which the elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Okay, so there are total 8 electrons are there, and and their electron capacity of the third shell is 18. So why this is so? So student, the third period contain only 8 elements even though the electron capacity of the third shell is 18, because when the other shell get filled and the resultant number of electron becomes 18 and it gets added up and settles in the third electron shell, and 3 shells are acquired by the fourth period. Alright, so that is why the third period contain only 8 elements even though the electron capacity of the third shell is 18. So student, that's it for today's video. I hope you all have understood. Thank you.